Anyone not know Jim? Jim's a smart guy, a Ruby guy. He's going to teach you a lot. So, what you got? Anyone else want to introduce Jim? Well,
I love you, Jim.
all right.
Hey, man,
okay.
I love you too.
All right, so that's the fancy introduction, Jim. So,
Okay.
here's Jim.
Let me go ahead and put the, yeah, there we go. There's the microphone. Awesome, awesome. So, before I start the official talk, I made a vow this year that every talk I do, I'm going to mention flying robots because I'm having so much fun with that. And here you can see, it's really, man, you can't read that at all. This is actually a program that controls my drone written in Ruby. I create a drone, I tell it to take off, then I go through a loop here 2 times, go left, right, hover, and land. I'm going to start the movie here. This has nothing to do with the talk, this is just fun. Okay, so I hit the return, I got 5 seconds to make it across the room. This is me moving really fast across the office. And it takes off, and right, left, hover, and land. And there you go, controlling flying robots with Ruby. Did everybody see Karen's talk today? That was awesome. She's in my office. We share an office there. We're all in the same place, and we're doing drones and flying and controlling with Ruby and controlling with Clojure and just having all kinds of fun back in Cincinnati. So there you go. So that's flying robots. And now let's get into the talk. And I'm here to do a talk called Kata and Analysis. How many people work code katas on their own time? Okay, man, it's hard to see. How many people do not? Raise your hand if you do not normally do code katas. Okay, so let me tell you what a code kata is. A code kata is a very simple, this sounds a little loud, I'm going to move it down a little bit. You still hear me? Yeah, that sounds better in my ear. A code kata is a simple exercise that you do over and over and over again to practice coding skills. Now you say, if it's so simple and you do it all the time, what can you possibly learn from it? What you learn is muscle memory. You learn to do the right thing at all times so that when you're working on your production code, you automatically do the right thing. The katas are there to train you to do the right thing, to do the test-driven approach, to refactor when you need to not refactor while red. All these little skills that we want to build up, katas are good for reinforcing that. So I am going to perform, this is actually a performance piece. I'm going to perform for you today a code kata, and then after I'm done, we're going to stop and going to analyze some things that we learned through doing the code kata. Now, let's see, I have 1 hour and 15 minutes, I think, for this talk, which is way longer than I normally have for this particular talk. So I'm going to actually do the full kata today. Normally I just do half of it, and then I do my analysis, but we'll take the time. I think we have the time to do the whole thing. So we'll just see how that goes. And so our kata that we have chosen for today's performance is converting numbers to Roman numerals and back again. So it should look something like this. You create a Roman numeral converter object. You use that converter. It's got a method on it called convert. And if you give it an Arabic number, it converts it to the Roman numeral equivalent. And if you give it a Roman numeral number, it converts it to the Arabic equivalent. And just a note here, we're just only worrying about the canonical Roman numerals. We're not going to worry about weird things like an IC. That's kind of non-canonical. So we're not going to worry about things like that. So we just have to worry about the regular things. And that's all the scope is for this. Now, of course, if you ever have to write a production Roman numeral converter, I'm sure someone has, right? You might want to handle these corner cases, but we're not going to worry about that. So, without further ado, we are going to start our code kata. Okay, so here I am. I'm in this directory. You can see it's RNC number 15. So this is the 15th time that I've performed this kata. Not all of them have been live. A lot of them have been just practice sessions. But I've got nothing but a rake file in there. Oh, by the way, I'm going to be using Ruby today for my code. Any non-Rubyists in the house? Yeah, okay. If you have questions on what I'm doing, or you say, Jim, that code looks weird, or I don't understand what you're doing, feel free to interrupt, and I would be happy to explain it. But Ruby is fairly readable even for the uninitiated, so I think we'll be okay sticking with that. Okay, so let's start. I'm going to open up a file. I'm going to call it Roman numeral converter spec.rb. And I always start with the spec file. And I'm going to use a library called rspec-given, which is a little testing framework written on top of rspec, which is a standard testing framework for Ruby. And we start off by describing a Roman numeral converter. There we go. And so, what's our givens? Let's say we're given a converter, and it's created like this, .new. That kind of matches the pattern that we saw in the slide. We want to create a Roman numeral converter like this, and so our given is this converter. Now I'm going to use that. So with that given, when I use the converter and call convert on it, actually let's keep it simpler. Let's say then the converter is not equal to nil. And I'm going to do one thing real quick here. This is just a configuration step. Okay. So when I run this test, it fails because it says, let's see, uninitialized constant Roman numeral converter. So I haven't even, no, that's my Windows off screen there. There, everything fits on. Uninitialized constant Roman numeral converter. So let's go back, and I'm going to put that in a file, require Roman numeral converter, like that. And then I need to create the file. I'm going to create a class called Roman numeral converter, end. Okay, that should be enough to pass our test. Cool, we got green tests, I'm done. Thank you. You should always clap for green tests. Green tests are exciting, and we love to see them. Okay, so this is actually a pretty stupid little test. I'm not doing anything other than creating the object and then making sure I actually got one. So now let's make an interesting test. Then, converter.convert, and where do I want to start? Let's start with a simple one. Let's start with 1. When I convert 1, it should equal the letter I. Let's run this, and it says it failed undefined method convert for Roman numeral converter. So I don't even have a convert method yet. Let's fix that. Def convert, it'll take a number. Okay, let's run our test. It's still failing. Now it says, oh, we expected nil to equal I. And then we get a breakdown of everything that failed. So the comparison was false. The converter itself returned nil, and we really wanted it to return an I. Well, that is easy to fix. Run our tests. And now we got 2 passing tests. Thank you. Yes, clap for green tests. Absolutely. Now, once I'm going to go back to my test here, I'm going to actually get rid of this test here. This was a good test to kind of make sure all my files are set up right, and I was including the right libraries and the test specs were there. But
You lost your mic.
yeah, so what happened with my mic? Says I got a red battery light here, man. Testing, testing, I am back. Woo! So this test was just kind of to get me going. It's not going to provide me any valuable feedback in the future. So I'm just going to get rid of it. And I have no problems with creating a test just to get past a particular point and then getting rid of it when it no longer serves its purpose. If converter is ever nil, this test will fail to begin with, because then I'll be calling convert on a nil object. So this is a good, so it's okay to get rid of that. So where do I go next? I can convert a 1 and the test pass. Yes, they still pass. Where do we want to go to next? Maybe 2. And that should return I. Run the tests, and we have a failing test that says we expected a single I to equal a double I, and it turns out our converter is returning just a single I. So that's, we need to fix this. And so we've got to return the number of I's that match the number that we're passing in. So let's just do that. Now this is a little bit of Ruby code here. This is unusual, but if you have a string and you multiply a string by an integer, here, let me show you. I'm going to drop into an interactive Ruby session. So this is just Ruby, right? I can type any Ruby expression and it evaluates for me. If I have a string Jim, okay, and I take the string Jim and I multiply it by 10, it gives me 10 Jims. So that's just how strings and integers work in Ruby. That's just a part of Ruby there. So I'm going to take this, I'm going to multiply I by the number, and that should give me the right number of I's. And let's see if we get that, and green tests! Okay, what should we do next? 3 is the next natural progression here, but 3 is not going to force me to change any of my code. Testing for 3 will not give me any more information, so I'm going to skip 3. The next one might be 4, but I know that 4 actually looks like this in Roman numerals with an I and a V, and that might be a special case. And so I'm actually going to skip 4 for right now and go to 5. I'm putting off the special case until I understand the general case. We'll come back to 4 eventually, but I want to do 5 next. Run our tests. We should have 1 failure, and it says we expected 5 I's to equal a V. Our converter is returning the 5 I's here. So we need to fix our code. And I think the easiest thing I can do here is just check to see if the number is 5. And if it is, return the V. Otherwise, return what we did before. Sound good? And 3 tests pass. I like that. Very good. I love it. What's next then? How about 6? 6 will be interesting. 6 is the first number that combines 2 different symbols in the same output. So I think this will be an interesting test. And we'll run this and we will see. Oh, thank you. This is why we pair program. Or what would this be? Crowd programming, yes. Crowdsourcing. Crowd code sourcing. And it fails. The failure is, we gave 6 I's and we wanted this. So that's really interesting. I didn't get any V's at all. And if I look at my code, I see that I'm testing for exactly equal to 5. And I really want to put a V in there if it's at least greater than 5, greater than or equal to 5. So let's change that test there. I run the test. I know it's not going to be right yet, but we get a different result. Now we're getting the V, but we're not getting the I's added to it. So that means I need to go here, and I need to actually break up my code. I need to build up my number incrementally, I think. If it's greater than 5, I want to put a V into it, and then I want to put the number of I's that I need into it. So let's build it up incrementally. I'm going to create a result that is an empty string, and I'm going to return the result at the end. There we go. And let's build it up incrementally. If the number is greater than 5, let's shove a V into the result. The double less than symbol is called the shovel operator in Ruby, and that just appends whatever on the right-hand side onto the string or array that's on the left-hand side. So that'll add a V to there. And then let's just shovel in the number of I's that we need, and then we'll return the result at the end. And this is not going to be right because I'm getting too many I's in there. I'm still putting 1, 2, 3, 4, I'm putting 5 I's? Yeah, that does. Oh, yeah, that's the 5 that's failing. So I broke the 5. What I need to do is actually reduce the number as I take into account pieces of it. So here I've handled the 5-ness of this number. Let's reduce the number by 5 by subtracting 5 from the number. Then down here, we will only add i's if the number is greater than or equal to 1. Actually, no. I don't even need to do that. Because this could be a 0, which means I get 0 i's in there. I think this will work. Let's try it. Yes! Green tests. I got you guys so well trained. Okay, so 6 is working. So we got both v's and i's in the same number. 7 I don't think is going to be very interesting because it won't force us to change our code. We're already handling that. 8 the same way. 9's another special case. Let's go to 10s. Oops. So 10 will be an x. 10 is here. Run this, and it fails. Oops. And run it again. There we go. It fails. It's giving me a v and then 5 i's, and it should be an x, so that's easy to fix. Oops, here's the code. I think I can just do the same thing that I did with 5, except put a 10 in there. Subtract by 10 and change this to an x. That should handle the 10s. Cool. Let's go to 20 and have 2 x's in there. And I know this will fail because I've only set up my code to add 1 x at a time. And we can see that we're getting out of it an x, then a v, and then 5, 1. So it adds up to 20, but I really wanted the double x in there. So what I need to do in my code base, instead of saying if it's greater than 10, change that to a while the number is greater than 10. So while it's greater than 10, keep shoving x's onto my result and decrease the number by 10. Eventually that will bring it down under 10, and then I can handle any remaining v's, and I can handle any remaining i's. And this should pass. Yes, it does. I love you guys. Okay. I think I'm ready to handle special cases. Let's think about what we have to do a for. So let's go back in here, and I'm going to add a for to my test case. Oops. Capital I. There should be a for there. Run the test. And it fails because it's giving 4 i's, and I want the special case IV. I think I can go in here, and I can do this kind of code again. I'm beginning to see that 4 is not nearly as much of a special case as I thought it was. But that's okay. I delayed the 4 till I could see what the general pattern was going to be, and I think this will work. And it does. Thank you. I think 9s will be the same thing as a 4. Run the test. It fails the way we expect. Okay, very good. Come in here and we will add code to handle a 9. IX and subtract by 9, run the tests. Oops. And 8 examples passing, green. Okay, so now I got to stop though, because this code is getting a little bit crufty. You're laughing, yeah, maybe just a little bit crufty.
I just like the word.
I feel there's a lot of duplication in this particular code base. Where? Well, okay, so we've got 3 instances of an if right there that are exactly the same except for the numbers and the Roman numeral glyphs that I'm adding to the result. But here, this looks a lot like the ifs, except it's a while. And then down here, we got something that's entirely different. I would like to introduce some more duplication before I get rid of duplication. I'm going to start by looking at this thing, which is way different than everything else. But I recognize that it is nothing more than a while loop that says while the number is greater than or equal to 1, shove an I onto the result and decrement the number by 1. And this should still work. Yes. because I've got good code coverage on my unit tests, I can make a refactoring like that. I recognize this code should be the same, make the change, run the test, and say, yes, it actually is the same. So I'm quite confident that was a good change there. And now I've got three variations, I reduced 3 variations down to 2 variations. And I'm going to make a really wild leap here at this next step. I'm going to claim that an if is nothing more than a while that's done. Actually, let me say it again. An if is nothing more than a while that's only done once. Let's see, if I change that if to a while, it still works. I change this to a while and this to a while. We're still good. Now I've got rampant duplication. And look at all these. These are all identical except for the number and the glyph. So the differences are only in data right now. So let's create some data up here. We'll call it Roman glyphs. And it's going to be an array, if I could type. And this array is going to be a pair of the limit, the numeric limit, and the Roman numeral glyph that's associated with that limit. So now let's concentrate on this very first while. I'm going to go take my Roman glyphs, and for each pair, I'm going to get the limit, and I'm going to get the glyph. And I'm going to put this inner while loop right there like that. I'm going to change this to use limit, this to be glyph, and this to be limit. So what I'm doing, so a little bit of Ruby code here you haven't seen yet. This is an array. Each will walk through each element of the array and assign the pairs into the local variables limit and glyph. So this will be, so the first time through this loop it will be 10. This one will be x. So I'm just doing the same exact thing I did before, except walking through this loop multiple times. And there's only one element in this list so far. But I can run this, and you can see I haven't made any changes yet. It still works. Nice. So now let's add the other glyphs in there. Let's add a 9 in there, and that's like that. Nice. How about 5? I'm going to be bold. I'm going to do a couple at the same time. A 1 like that, and run this. It all still passes. So now this first loop is handling all the reduction of the number, building up the result and reducing the number down to 0. So by the time we get down to there, these while loops here are doing absolutely nothing, and I can remove them. And we got it. At this point, this is the entire code base that we have, and we're converting everything up to anything that handles x's, i's, and v's. We can handle any of those. It is at this point painfully obvious how to complete this. So I'm going to incorporate a bunch of steps all at once. I'm going to go ahead and just finish out the implementation here. I'm going to start by going ahead and writing some more tests for that. So let's add a 40, which would be XL. I'm just going to hit the high points here. So we have an L is 50, and we have a 90 that will be XC. Okay. Take all that. See, I don't want the 20 anymore in there. I'm going to change this to be 100, 400, 500, and 900. And that will be a C, a CD, a D, and a CM. And then we have 1,000 right here that is just an M. And that should pretty well round out our Roman numerals there. And of course, there's lots of them failing. We have 8 failures out of that whole mess there, but that's because I haven't implemented the other pieces of the table, and we'll just go ahead and do that real quick. So this is the 40, the 50, the 90. 90 is XC, 50 is L, this is XL. And do this for the next power of 10, 0, 0, 0, 0 there. So we got the hundreds in there, and this is CM, this is D, this is CD, and this is C, and we got our 1,000 in here now. And run the test. And now I got everything working. Now, all these tests just hit the high points, the things that I needed to make sure were in there to complete my table. Let's check for some edge cases. I always like to convert the year because years are used a lot for Roman numerals. So this would be 2 M's, an X, and 3 I's. Oops, what failed? Converter. Okay, that's good. And I expected it to be good, but I'm just kind of double checking some odd cases. I think the largest possible number we can convert with this technique is 3,999. And that will be 3 M's, a 900, which is CM, a 90, which is XC, and then a 9, which is IX. That's good. And maybe one more edge case. What happens if I convert a 0? Roman numerals does not have a concept for 0. So now I've kind of got to decide. I can either not test for it and let it be unspecified. I can say this throws an exception. I can say it returns an empty string. Any preference? Empty string. And I like that because that just works. So I'm happy with that solution. So we were looking at something that was kind of outside the specs. We had to make a call. Now, if I were doing this in real life, I'd probably go back to my user and say, hey, you didn't really tell us what you wanted to do in this case. What behavior do you want? And get some feedback. If it was a user-facing feature in that, if it was an internal implementation detail, I wouldn't bother to do that. I'd just make a call based upon what was most convenient for development. But I'm quite happy with that. Oh, -1. Ooh. I've never tried a -1. What do you want it to output? -I. Oh, I'm so into this. And it fails. We expected, so it returned a blank, an empty string, and we really wanted it to be a -I. Interesting. Interesting. So let's look at that. If number is, let's put it here. If number is less than 0, number gets minus number, and result gets a minus sign. Nice. Okay, cool. Now this is normally how far I take the Roman numeral kata. We stop and do analysis at this point, but let's see. I've got another 40 minutes yet before I'm done, so I'm going to go ahead. I've never done this live. I'm going to do the other half of the Roman numeral kata, and you guys get to see the first time I've tried doing it in front of people. So this might be the exciting part of the talk right here. So we want to go the other way. We want to be able to convert Roman numerals back into Arabic numbers. And I'm going to go to my tests here. And I think what I'm going to do is I'm going to add a context block here. When converting from Arabic to Roman. And I'm going to put every test I've done so far inside that context block. Re-indent everything there, okay. And then I'm going to take the entire context here and duplicate it and change the words around when converting from Roman to Arabic. Now, I only do this for organizational purposes. There's no reason why I couldn't just keep putting then, and just reverse things. But because they're two separate contexts, it's kind of nice to break them up like this. It gives my tests a little bit more structure, and I like that. And now I actually have to change this. And so we're going to do it like this. I'm going to say, search for a parentheses, search for closing parentheses, cut that, search for quote, paste the number in here, search for a quote again, cut that, search backwards for parentheses, paste that there, go down to the next line and finish that keyboard macro. Oh, this will be interesting down there. Okay. Nice. Okay, so let's run the tests. Whoa! 20 failures. Oh, I don't know where to start. Actually, I think what I'm going to do is half the tests are failing, and we know they're failing. We expect this because we don't expect them all to pass right away. I'm actually going to take a lot of these tests and just comment them out for the moment. So when I run my tests, I can see the one failing test I want to fix right now, and everything else should be green. If I did not do this as I was passing tests, I would fix one, and then I'd get 19, or I'd get 7 failing tests, and I fix another one. I get, so I would see the number go down, but it's so much better to see green when you got something working, and I can incrementally fix that. So let's see, which one did I do that? Okay, so this is an easy one. Converter, convert an I to a 1. Okay. Still the same method, right?
Okay, you plan to use the same method.
That is, if we look at the spec says use the same method and kind of auto-detect. So what I need here to say is if number is a string, then return a 1, else do all this stuff. Okay, so now I got a big else in this. Oh, this is getting crufty again. Let's run this. And look, I'm getting green tests. It was really important to me to comment out the failing tests. Or if your test framework allows you to mark them as pending, that would be okay too. But this allows me to just concentrate now on uncommenting them one at a time and fixing things. So this is good. Let's see here. I've got to refactor this because this is way too crufty here. Let's take all of this out. And let's create a method called convert to Arabic and pass in our number. Yes, thank you. Pairing for the win, absolutely. I would have noticed that eventually, I'm sure. Okay, let's re-indent this so it looks pretty again. That looks good. Run my tests. And they're all passing, so that was a good refactor. Yeah, you can keep clapping, that's okay. I know it gets boring after I've done this so many times, but yeah. And actually, this was an extract method refactoring, where you take code and extract it out into its own method. When I do that as part of refactoring, and this extracted method is not intended to be part of the public interface, I like to mark it private at that point. So let's change it to private and make sure it still runs. Yeah, that was a good change. And rather than return 1, I'm actually going to say convert to Arabic here. Pass in number. Def convert to Arabic, pass in my number. And that's a good refactoring too. Yes, it is. Good. Okay, so now I can concentrate on changing this method, and this handles the decision on which way to convert, and the details of the conversion are down here. So I like that. That's good. That's good. And double check, everything still works. Let's look at the next thing. Let's do this one, 2. And that fails because we expected it to return a 2, and the converter is just returning a 1. Not surprising since I hard-coded it to 1. People laugh sometimes when you do this hard coding, but it really makes you stop and think about what is the test I need to write to get rid of the hard coding. And we can do this now, number.size. Okay, I don't think this is going to last real long, but it works and it passes, so I'm going to leave it. I'm going to skip 4 again, because 4 is a special case, and let's understand the general case first. But 5 is a good one, and 5 will fail because the size won't be right. Yep, expected 5, I got a 1, haha. Okay, now I got to do something real. I need to go through, I think probably a good approach to this is to go and break this, the string up into individual characters, look up the Roman numeral value for that character, and then just add them all together. Does that sound like a good approach? I think that might work.
Should your giant case of numerals to integers be private as well?
The constant up here?
Yes.
It wouldn't hurt, but you can't mark constants as private in Ruby. So that's, yeah, but yeah, if I could, I would, yeah. Yeah, because method lookup, methods are the only thing that are private, that you can mark as private. Constants are not. And that's because actually in Ruby, private has a slightly different meaning than it does in Java. In Java and C# and most other languages, private is a class-based thing. In Ruby, private is an object-based thing. And the constants aren't in an object, so they don't participate in the private nature of things. But I'm getting a little off topic. Okay, so I want to take number, and actually, yeah, number, and I want to take each of the characters, and let's create a result that's initialized to 0 and return the result. And then in this loop, what I'm going to do is I'm going to take this character, find the Roman value for the character. I haven't written Roman value yet, but I just imagine I need a function called Roman value that adds the Roman value of that character to the result. That should be plus equals. And this will fail because Roman value isn't defined anywhere. So now I just need to define Roman value, takes a character, and let's just make it easy. Case, CH, when it's an I, the value is 1. When it's a V, the value is 5, and that works. You aren't impressed with this code. I can tell by the very weak clapping that was done. Okay. Actually, now that I think about it, I think this could more easily, but forget the case. Let's just create a hash object. I maps to 1, V maps to 5, close the hash, and then we index the hash by our character, like that. Why not reuse the map up here? Well, this is interesting because this is not a map. This is actually an array of pairs. I could actually I could do this actually. Roman glyphs each do, I'll get a limit and a glyph. And if the glyph equals the character, then let's return the limit yeah, and that works too. Let's not do that though. I'm going to wait on this. I'm going to allow the duplication to exist for right now. In fact, I'm going to pull this constant out and make it a thing called Roman values. Create a constant that is our hash here. And then call Roman values inside the method called Roman value. And that works like that. So I'm going to let this duplication build for a while, and then we'll resolve it later. I like to do that. I like to let the tension build up, but remembering that I'm going to refactor it later. So actually, we could even add a to-do duplication here. Okay. Actually, okay, where's my tests? There we go. And down here are my tests. So that handles 5. I think we can handle 6 too, right? Yep, that works. 10 will fail because I don't have x's in there yet, right? Yeah, because it's saying nil can't be coerced to a fixed num. It's on this plus right here. That's because we're looking up a Roman value and it's failing. So all we need to do to fix that is to go ahead and start adding our x, which is 10. And I'm going to be very liberal here and go ahead and do a bunch of them because this is going to be a pattern that's going to be repeating, and I know it is. C, D is 500 and M is 1,000. That fixes. Okay, so that means I can go into my test now, and this 20 should work. The 40 won't work yet. Hang on. But the 50 will, the 100 will, the 500 and the 1,000. All of those should work now. 2013 will work too. Okay. This one won't. I don't know about those yet. Let's see what we get. Yeah, we're good so far. We got a whole bunch of them passing now. You think the 399 won't yet? Nope, it still fails. So I don't want to handle the big one yet. Let's do an easy one first. So let's concentrate on 4. It's time to go back and get our special case. So 4. So So when the rule is when a lower value precedes a higher value, you subtract the lower value rather than add the lower value. So when I precedes a v, you subtract the I or subtract a 1, and then continue on as before. Likewise, when I precedes an x, then you subtract 1 here, and then you add the x, and that would give you the 9. Subtract a 10 from a 50 would give you 40. So if a small value is before a larger value in the sequence, you want to subtract. So I want to write some kind of code in here that says if something else, I can't type else, if something, then we subtract the value, otherwise I add the value. And I'd want to do it when the number, when the character I'm looking at its value is less than the value that comes immediately after that. Now the problem with this is that as I'm walking through all the characters in my string, I only have access to that particular character. This particular technique does not allow me to see the values that come after it. So I would have to change this into some kind of explicit loop and pull the characters out so I can pull out the current character and the following character.
Could you just use each chunk
Oh, each chunk?
and take two things?
I've never used each chunk. So how's each chunk work?
You give it how big of a thing to take, you would tell it to take two things, and it would pass in two arguments.
Is each chunk like this?
Yeah.
So I'm going to just try this interactively at the command line. Undefined method, each chunk.
Maybe just A has two things in it.
Well, no, it's not. It's not finding the method each chunk.
Each slice, maybe.
So let's ask an array for its list of methods, and let's grep that for anything that has each in it. Each slice. Let's try each slice then. Do I have to tell it how big the slice is?
Yes.
1 and 2. Oh, no, but then it's going to skip 2. I want to have 1 and 2, then 2 and 3, then 3 and 4. So,
Can you move backwards?
Can you use each with index?
I could use each with index and then pull the next character, add one to the index and just explicitly pull the thing out. I like that. I think I can do it like this too. Each with index A and B puts A and B. Yeah, that's, oops. Okay, so let's go into code and let's say each with index, and then I'll get an index out of it. And so I can get so let's get the value here. Let's get the next value to be the Roman value of number indexed by I plus 1. Okay, then if the value is less than the next value, then I want to subtract the value. Otherwise, I want to add the value. How's that look? No one's committing. Big change, but you know what? We have a bunch of tests to see how we're doing. So let's run the test. I think we're going to get some comparison of fixed num with nil failed. That's because when we get to the end of the string, I'm getting back a nil value, so I have to say if there is a next value and the current value is less than it, then we subtract. Woo! Nice, nice, okay. Okay, very good. Let's see, let's go back to the test. And that handles, oh, I didn't even uncomment 4 yet. I have approved a thing. I didn't have a failing test. I changed all that code without a failing test. Okay, let's uncomment it now and see if it passes now. Oh, woo! You guys let me down. That's the job of the pair partner, to make sure that you don't do things like that.
Still changed on green.
Yeah, I changed on green, so it was a refactoring. Okay. And that works, and actually I think all of them will work now. It's all good. Let's get down here. This one should be good. I don't know about the other two. So yeah, that's good. Let's do the empty string. Oh, that works too. Nice. And the negative one I bet will fail. Yeah, because it doesn't know how to handle a dash. And I think we'll do the same thing we did in the other place. If number matches a pattern such it begins with a dash, then Then convert positive convert to
Replace the dash with nothing and then
actually this is what I'd want to do. Convert to positive Arabic. If number, oops, there, that character right there begins with a dash, then I'm going to call convert to positive Arabic on the number beginning with the second letter, which will be index position 1, to the end of the string, and return the minus of that. Otherwise, I just call convert to positive Arabic on number. Yeah.
Can you check, can you delete a dash and if it returns something, then do that?
I could, but then I would have to remember to do it at the end. And by doing it this way, I don't even have to change the string. I just pass the substring down in, and I remember right here to put the minus sign in. If I added it here, deleted the dash, I'd have to have an extra variable that remembered that it was negative, and then at the end have an if that flag was set, then change it to negative before I return it. And I like this solution much better. In fact, I like it so much, I'm thinking my Roman numeral converter should do that too. Convert to, okay, let's make sure everything works. Before I refactor, let's look at all the tests. So all the tests are now uncommented, good, and they're all passing. Let's do the refactor. Okay, convert to positive Roman. Okay. Take this out, move it here. The number is less than 0. Then we return convert. No, I return a string that's a dash and concatenate it with convert to positive Roman number, minus number. Else, just convert to positive Roman number. And that still passes. I like that solution much better. So this is what we do. We go through and we clean this up. And look, it made this was beginning to get a little bit crufty in my minds because of that if-then test in the beginning. And let's just pull it out and make a separate method of it. These are all private methods. They're all implementation details. We should be able to change any of this stuff without affecting our test. And that's a sign of a good set of unit tests when the internal implementation can change, but the unit tests do not break because of that. So that's good. I like that. I've been wondering if this could be broken out somehow. So this code right here has 2 nested loops. And I'd really like to take this code out and replace it with something in here and move it into a separate method, just that while loop there. But if you look at what it does, it says while number is less than limit, we modify the result and then we modify the number. And there's just no clean way of pulling that out into a method that I don't think is less confusing than what 2 nested while loops are. There's ways of doing it. I could say, since we're modifying both the result and the number, I could say result comma number and return 2 things from a function. The function might be called reduce by limit. Then I have to pass in the result. I have to pass in the number, I have to pass in the limit, and I have to pass in the glyph. Okay, I'm already beyond my line limit here. There, like that. So we could do that, but I don't think that's any more readable. I don't think that buys us anything. Any agreement, disagreement? Agree? Okay. So I think I'm just going to leave the nested while loop in there. I'm okay with that. Make sure I didn't break anything of all that editing. Okay, that looks good. So this, I like the test for positive there. You know what? This extra test in here, we have this and test in here because we got to make sure we get a next value. Next value comes from Roman value, and that means this method can possibly return a nil. And let's fix Roman value so it can never return a nil, and then I can get rid of this next value test. So we can do that by going down here and saying it's either going to return whatever in the array or it's going to return a 0. And a 0 is the perfect number to return because the value is always going to be greater than 0, so we will never trigger the negative on the last step, which is exactly what we want. I can do this and it still passes. Now I can go in here and this test here goes away. Nice. So we've made this test much simpler, and we did so by making sure that this function always returns a valid value. It was sloppy before in that it could return a nil. By improving the internal method there, we've made the test actually easier, and I like that.
That function, you just change that like a coalesce, find the element in the array or return 0.
Say what?
Is that like a coalesce?
Oh yeah. So this is an OR operator, and so this, and in Ruby, nil and false are false values. Everything else are true values. So if this array does not have the element in it, or this is actually a hash, if it can't find the hash element, it returns a nil. So if it returns a nil, then the OR clause kicks in and says, okay, we're going to return a 0 instead. It's a fairly common Ruby idiom to say this value or something else. And that means if this value is nil, then the second thing is the thing we return. So you could make it very explicit by saying result is this. If result is nil, result equals 0, and then return result. So that would be a much more explicit way of writing it. Yeah, and it still works. But truthfully, Rubyists would probably rarely write it like that. So, oops. Make sure I don't break the code there. Okay, and everything's still good. So, yeah, so that's what the OR is. It's not so much a coalesce as much as either this value or this value. Okay, cool. I have a note here to handle duplication. How am I doing in time? Ooh, we are getting close there. We need to move to the analysis phase very quickly. You know what? There's another way. Let's just do this. Let's create an empty hash. And let's take our Roman glyphs. And for each glyph, we will get a limit and a glyph. And let's populate the Roman values hash based upon the glyph with the limit. So here I create an empty array, and then I iterate over the existing glyphs that were defined up here, these guys. I iterate over those and use that to populate the hash. Oops, where to go? Here it is, up here at the top. I use it to populate that hash. So I'm executing code to fill it, and that's good. That still works. I'm putting extra values in there, but you know what? It doesn't matter because I'm not using anything but the single letter glyphs to look up. I think that's fine. So that's got rid of the duplication. I'm going to actually take this out of here and move it up here with the other constants, so it's all up at top. And let's run that, and we're done. And I'm going to stop it there. I think there's some more cleanup we could do in this code base, but I do want to get to the analysis part. We've got about 10 minutes to do that, and I think this is a valuable part of walking through this. So let's talk about what we just did. Whenever you start a set of unit tests, knowing where to start is important. A lot of times people go, I don't know what to test first. I don't know where to go with. My solution for doing that almost always is to, you start describing what you want to test, and you put in a really dirt simple, stupid test. This object is not nil. And this kind of starts the creative juices flowing. This makes sure all the mechanics are in place before you start worrying about the details of what you need to test. It just kind of gets you in a place where now you can actually start testing. So knowing where to start is a good thing to do. I also like to start with the simplest case possible. In the Roman numerals, converting a 1 seemed to me to be the simplest place to start with that. So I like that conversion. Know where to go next. And this is a key when doing test-driven development, is that you know where you want to go in your solution. Generally I'm not coding blind. I know kind of the shape of my solution, so I pick tests to force me to write that solution. So I know I need to handle multiple i's, so the next obvious test should be a test that forces me to write multiple i's. After I get that working, I need to continue. So I use my knowledge of where I want the solution to go to drive the next test. So i's are working. I need to handle v's now, so let's add a test for that. And that forces me now to write more code. That's the if then else. Now I know the if then else is not complete. It works for my given set of tests, but it's not complete yet. And I go and I need to get rid of the else now. So that is the 6 that adds this and makes me start to do an incremental solution, which is kind of one of the fundamental things here to get there. So we got incremental solution where we're building up the result piece by piece. We handle the 5-ness of the number first, then we handle the 1-ness of the number. Knowing that I have to reduce the number as I go along is a key part of that. Handle multiple x's. Change that if to a while. That was key there. Knowing what to skip is important. I skipped the 4s because I knew 4s were a special case. Turned out they were not as big of a special case as I thought they were going to be. At least in the first half. The second half, yeah, they did turn out to be kind of a big special case. But I didn't know that when I was first starting. And I always like to understand the general solution before I go and start exploring special cases. So delay working on special cases until you feel that you're ready to handle it.
How big of an impact is it if you don't know what you're getting into and you hit that?
If you hit something, it may cause you to wander off into solutions that are overly specific. Because you don't know what the general case is yet, you might start handling special case, and you might end up with code with lots of ifs in it, perhaps. There's the danger in that, so yeah. Recognizing duplication is important, and I think this is key. When we got to this point, we had 3 different styles. We had while loops, we had if statements, and we had this star statement there. Recognizing that those were all the same thing that needed to be reduced was a big step. Getting rid of the star gave us 2 variations, getting rid of the ifs gave us a single variation, and then that allows us to collapse everything down into a data-driven approach. And truthfully, if I start off, a Roman numeral converter is not hard. You could probably sit down and write it straight out without going through all these testing steps. But that's not the purpose of the kata. The kata is there to do something easy and to force you to do these step by step, so when you get to really hard code, you have the patterns ingrained into the way you approach problems. I doubt I would have stumbled on this particular way of doing it had I started out just writing the code up front, thinking really hard about it. I think the incremental approach actually led me to this solution that I would not have come up otherwise. Now I've done this enough these days that I kind of naturally, I know where the solution's going. Like I say, I've done this 15 or so times. But the very first time I did this, I was absolutely astonished that the solution came out. It was not what I was expecting at all. Other possible duplication things you could look at. We're doing a lot of converter.convert in our test cases. Sometimes I go through the bother of changing that and having a method call to do that. There's lots of refactoring we could have done in our test cases that we didn't do. But that's a fertile place to look for possibilities there.
How do you feel about generating specs?
I do not like generating specs. In fact, we'll get to that, I think, here in a moment. So by taking all these into converts and putting in a method, that means if I ever change the convert method and have a to-Roman method, there's one place I need to do that. Not a big deal in this test case, but if you need to create a lot of objects all the time, centralizing how you're creating them is a good way to do that. So this is good here. Knowing when to leave in duplication. We're going to get to your thing here in just a second, though. So here, there's a pattern in our conversion table that these four things, the 1, 4, 5, 9 pattern, repeats 3 times in our table. This is duplication. Should I work in removing this duplication? I could do it by something like this. Yuck! This totally obscures the structure of the table in my mind. Even though I've removed the duplication of the knowledge of how the 1, 4, 5, 9 pattern works, it's totally obscured by going this route, and I would not recommend it. I like this, where the pattern is clearly visible over something like this. Just my feeling. Again, this kind of, you talk about generating specs. You could go from this into something like this. Personally, I think this is fine. It lines up, I can see exactly what I'm testing. If I'm doing something like this, one failure will cause the following ones to not run, so that's not so good. I will get line numbers reporting to me where the line occurred, and it will always be on this next to the bottom line that says convert. So it will not tell me exactly which test case it was that failed. I am, in general, not a big fan of generating test cases. I think that happened to me once when I was looking over a set of test cases where they were using metaprogramming, and they were looping over a set of methods to test, and you could see the 2 methods in the array that they were iterating over, but in the body, they forgot to replace one place where the method was called with the variable name. They were calling the same method twice in the generated spec. And it's too easy to make little slip-ups like that. Unless it's a big saving in duplication, I tend to not generate, do lots of metaprogramming, particularly in tests. Edge cases are important. Checking these things were good. Looking at 0, I think, was clarifying because it helped us look at things that weren't specified. Touching bases on some numbers that were otherwise not tested, kind of make sure that, hey, there's no pathological steps in our code base here. So I like to do that. So here's a quick summary of the things that we learned. If you Google for code katas and look for Roman numeral implementation, there's lots of examples out there. Some people would put their katas to music, so you can listen to music while they perform the kata on a video. There's a couple up there. And Enrique Comba Reppenhausen's one is particularly good. I like that one. RSpec given is the framework I'm using to do my testing, and I really like that. And if you want to work on something and you don't have a pair, there's the pairprogrammingbot.com website that will keep you on the straight and narrow path. So I think I am out of time. Oh, a minute left to go. Did I time that right or not? Thank you, yeah. Any quick questions before we take off here? Yes?
How much of the kata is self-discipline? You talked about leaving it a little crufty and having tension and then resolving it.
I do it different ways sometimes. I like doing a kata and varying the way I do solutions. In my practice session right before here, I actually did the full kata just to make sure I could do the second half and not do major slip-ups. And I solved it an entirely different way. I actually did it a little bit more functional, where I created my array of next values and zipped it with an array of next values shifted over one, so I had the number and the next value as pairs. That was kind of cool. I think this way is actually a little bit simpler. The functional way was a little bit obscured. But leaving your question was more about leaving the cruft in. I think you do that so that when you're in your real programming world, you leave cruft in, but you always remember to go back out. So practicing that in the kata, remembering to go back and clean up, I think is an important step of practicing the kata, so that when you get to real life code, you know that, hey, it's okay to leave it a little crufty for now, but you gotta come back and fix it. The whole thing about katas is practice, practice, practice. So in real life. So when your manager says, I need this done now, you don't slip into bad habits because you've practiced your habits and they are natural to you and you know how to do them. You just fall into good habits instead of bad habits. Any other questions? Was that good? Does that answer your question? All right. Thank you very much. You guys have a good day. We'll see you tomorrow.